Hey, what's up, guys? Chung here again. And today, today let's take a look at another LeetCode problem here. Number 1125, smallest sufficient team. This one is a hard problem. I, yeah, I like this problem. I think this is a really, really nice problem, and I recommend you guys try to understand this problem. Okay, let's take a look. Basically, in a project, you have a list of required field. You have a list of required skills in the forms of a list of strings. And then you have a list of people, and it's a list of a list. Basically, the ith person, people I, contains a list of the skills of that the person has. And it asks you to find the smallest team, uh, whose team members can cover all the required skills here. Okay. Yeah, for example, this one, right? For example, this one, we have a required skills Java, Node.js, and React.js. And we have three peoples here, right? People 0 has skills Java, people 1 has skill Node.js, and people 3 has people Node.js and React.js. And in this case, the answer is the answer is 0. The answer is people 0 and people 2. So basically, people 0 and 2 can form a team which covers all the required fields here. So, so this one is like a typical DP problem, but what's make this problem a hard problem is that it's not like a typical DP problem because you guys might have already know that for the typical DP problem, it always asks you to return either a minimum number or a maximum number or a count, right? But this problem, no, this problem asks you to return basically the path, right? So how did you form this DP solutions, right? Not only the final result, but also the intermediate state, like to form with the smallest team, right? So I mean, for the typical DP in this case, it only asks you to find the okay. So what's the smallest team that can cover this I and J? Okay, sorry, can cover all the required fields here. That in this case is going to be 2. This one is going to be 2, right? So that's I think if I ask you to do that, then I think this one going to be a medium problem. But this one asks you to instead of the 2 here, ask you to find out to give us the details of the 2. So which two persons in this case? So that's the first part we need to be careful. And the second one is the how can you efficiently check basically if the current one basically how can you check if the union of two subsets, right? So that we can quickly cover to check how can we cover everything, cover all the skills. So that's the second part it asks you to do. And the uh, and the required skills here, the length is 16. So every time when you see the 16 here, right? So what it tells you? It tells you is that the the combination should be like 2 to the times of n here, of 16 basically in this case. Okay, and uh, and then the second one is the people, the 60, the length of 60. So that's a 60. 60 times that. I think here it's gonna be a 3 million maybe, something like that. Okay. Hmm. Yeah. So, mm, so first thing first. how can we efficiently verify, right? Verify what's the new skills. Basically, let's say we have skills A, B, and C. That's the first person skills. And the second person have like let's say B, C, D, and E, right? Cool. So if we have those two teams, those two persons in our team, how can we, so the union of these two going to be A, B, C, D, E, right? So what's the efficient way? What's the most efficient way of getting this one? Okay, right? So I mean the easiest way may sorry, the naive way is gonna be we just store we just compare them one by one, right? So if there's an existing one, we just skip that and then we just scan scan this arrays two times and then we get this one. Okay, but here we have a better way of doing this. We can convert this like each skills into its binary format. Um, so it means that let's say the total skills, it says the all the people skills are each skill in for each person is a skill, is part of the required skills. So let's say the required skills is this. Okay, it's A, B, C, D, E. And we can use one to represent that skills. Okay, so five ones, that's our final result. Okay, and for people A, it has three skills. So the skill set value for people one here, this is two, is one, 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 zero, and zero. Okay, and the people two is since the first the zero, one, one, uh, one, one, right? And if we have those two values, when we try to union those things together, all we need to do is we just do a OR here. If we do a bitwise OR, we can simply get 1, 1, 1, 1, 1 in the end, right? Basically, that's the first thing we can use to basically instead of storing, basically we're gonna have a DP here, right? So DP here and DPI here. So the DPI here, the I means the how many skills we currently have, right? I mean, basically to have this many skills, right? To have this many skills, what's the minimum team members we have here? So the value is going to be also a list here because it asks us to return the actual team members instead of the length of the team. So instead of storing an integer here, we're gonna storing the list here, and that's the I means to cover this many required fields. Okay, right? So I mean, if we use the string here or the list here, we're gonna have like a DP, like a set, something like that, right? A, B, C, D here. That'll be too complex, right? C, D. So now, since we can use this like bit manipulation trick, we can just convert like this A, B, C, D into like a bitwise. Basically, this is gonna be an integer here, right? Okay, so with that in mind, and uh, and then our final answer, right? So what the final answer will be the DP or DP what 11111, right? That's gonna be our final result. In the end, we simply return the DP with the value 11111, which is the what the 2 to the time 1 2 3 4 5 uh 2 to the 5 minus 1, which is the 31. So, right, so that's a 31. Okay. Mm. Yeah, so with this one, all it left is we just for each of the person, okay, and for each of the new people here, and we just need to traverse all the existing DP values, okay, and we do mm, basically the current DP I, right, equals to mm, the DP uh, I or K. It's going to be the minimum, actually, the minimum, right? The minimum DP I or K. K is in the range of 0 to minus 1. Sorry, I minus 1. Mm. So, I mean, so basically, for the current ice person, for current ice people, okay, and for current ice people, for each skills this person has, okay, we're gonna try to add this person, let's say the current skill for this person. We're gonna union this current skill with the values uh, with other previously skills we have stored in this DP. Right. Basically, we're trying to for each of the current skills, we're trying to get the new skills, the new skill, the new skills, and okay, and that's basically this new skills is gonna be our key, right? The key in this DP, and for each of the new skills, we'll check. I mean, we will check because since we're storing the DP the skills and the length for this, right? Basically, we're gonna have like a dictionary here. So that the key is the skills, and the value is gonna be the list. Basically, every time when we have a new skills with current skill, we're gonna compare the the length of this new skills. If it is greater than the previously DP length plus 1. If that's the case, and then we know, okay, we have a better way, we have a shorter way to get to this current new skill state from the previously state. Okay, and then we'll update the DP new skills with uh, with the team member from the previously DP state plus the current ith person. And in the end, we simply return the latest the required skills from the DP. Okay, so let's try to code these things up. I know the explanation is a little bit confusing because because this I don't know. You know what? I'll try to code these things up. Maybe while I'm coding, I can explain a little bit more. Okay, so first we need a number of required skills, right? That's the number n here. Okay, and then so for the DP, right? Like I said, in DP we're gonna instead of we use a regular um, regular array here, since we're going to store the actual list itself. So I'm gonna use a dictionary here. So at the beginning, it's 0 and 0. So 0 and an empty list means to have 0 skills. We don't need anyone. Okay. And okay, so after that, it always left is we just do a dpi and people, right? In enumerate like people. Okay. So so first, right? So first, we need to get all the skills this person have, right? So to get all the skills this person has, we simply first. We need to loop through all the skills this person have, right? All skill in P, okay? And what do we do here? Like I said, we're gonna convert the skills from a string into a binary current um, people skill into an integer. Okay, so the way we're doing it for each skill, we do a people dot skill, we do a or, right? Or what? We can do a bit manipulation here uh, to the index. Okay, so since we have the name here, we need the relative index uh, at the original required skills list here. Okay, so for that to get that, we have to do a pre-process here. Basically, for each of the skills here, we're gonna make a dictionary where the key is the skill name and the value is the index of that. Okay, so we're gonna do a pre-process here. It's gonna be keys, right? Key indices. Mm, skill index, right? For I skill in enumerate require skills. Okay, so once we have this one, now here we can easily find the relative index, right, for the current skill. This is gonna be the index. It's gonna be this index dictionary dot skill. Okay, so why is that, right? Let's say we have a Java, Node.js, and React. Let's say we have a Node.js here. So the first one is Node.js. So what's the value of Node.js? So the Node.js index is one here. So if we do a move this one to the left by one, so we have 1 0. Okay, and if the React is the skill, now the React's index is 2, and if we move 1 to the left by 2, we have 1 0 0. Okay, and if we do a OR here, we have 1 1 0. Right? So that's how we convert this people skill into its binary form. We just get its relative indices position, and then we do a OR. Okay, so with the people skill, so now all we need to do is we just do a for each of the previous exist DP. Okay, we we have a previous skills, right? Skills and the team, right? In dp dot items, okay? Oh, one more thing here. Since we are going to update this DP, no, I'll do it later. Basically, the new skills or the updated skills, okay, people skill will be what? Will be the current people skill or the pre-skills, right? And we can do a simple check here. Basically, if the updated skills is the same as the pre-skills, basically if nothing has changed, okay, we don't need to do anything. We can simply continue, okay. Else if the updated skills is not in the DP, or right, if it's the first time, of course we have to add the updated skill into the DP hash set, or what, or the previous state is the has a better option, has a better option for us to make a shorter team, a smaller team. So that's the length of the DP updated skills, right? Basically, if this updated skills already exist, right, and then we check if this length is greater than the length of team, okay, then the length of team plus one, right? So if that's the case, what do? We do a DP updated skills equals to what? The team plus the current I, right? Oh, and that's what I'm saying. So basically, since we're updating the DP while we are looping through the teams, so we're looping through the DPs, we have to convert it into a list so that it won't be otherwise we'll get an error says, okay, you cannot loop through the DP item itself while changing the size of the DP. But if you convert this one to like a list, then basically you detach the previous state with the current state. Okay. And yeah, I mean, in the end, we simply return the DP. What? DP, that's the uh, for everything to get to the other state, the other skills. That's what we need to do. We move the one to the left by n bit, and then we do a -1 because here we need the DP 11111. That's our target. Okay. Uh, okay. Let me try to run this one first. Okay. So the test case passed. Yeah, it's accepted. Okay. So let me try to walk you guys through this problem, this solution one more time. So first thing first, we use the bit manipulations to join two sets of skills into one. And the way we're doing it, for each of the skill, we use these required fields to mark the position of each skill. For example, this like Java, the position is 0, and this is 1, this is 2. So, and in this case, so the Java skill will be represented by 1, and the Node.js will be represented by 1, 0, and the React.js will be represented by 1, 0, 0. Okay, and for everything, for all the skills, the final result will be 1, 1, 1. That's gonna be our final answer here. So basically, we use a DP hash map to store the final answer or the intermediate answer here. And the process is for each of the people, we loop through each people. Okay. So for each of the people here, we get all the people skills represented by its binary form, okay, which is like integer. And then basically for each of the current people, we will loop through all the previously DP states. Mm, to get the updated skills here. And yeah, so why didn't we only check the previously DP states which have the most skill sets, right? Because I think the reason being is we cannot guarantee that, right? We cannot guarantee that the previously DP state which has the most skills uh and with the current people skill can cover all the skills. Okay, that's why we have to loop through all the previously DP states, and for all the previously DP states, we have the pre basically that states all the skills and the number of teams. Sorry, the team members, right? Basically team members. And with each of the states here, we have the updated skills, which we also do a OR here, bit OR. Basically, we union those two skill sets together, and with the updated skills, we do some checkings here. Basically, if the updated skill is not in DP, of course, we will like we will make a new team, right? I will add this current updated team for this updated skills key here. Or if the previously states or the previous state plus one, which this one means we add the current people, the size is smaller than the current team size, okay? And then we also update our team with the current updated skills. And in the end, we simply return this value because that's the value, right? That's the and for example, if we have three skills here, right? So n equals to 3, okay? And then yeah, n equals to 3. And if we move a 1 to the left, right? Uh, basically we're adding 3 zeros to the right of 1. It's going to be 1 0 0 0, okay? And if we from that we minus 1, we will get a 1 1 1, right? Because that's what's the number of it? It's 8, right? So yeah, this is 8. 8 minus 1 equals 7. And basically we're checking the DP7 here. Uh, yeah, I think yeah, that's pretty much it is for this problem. I know I didn't explain it very well, but I tried my best because and this for this problem it not only asks you to figure out a way of doing the DP here, but also ask you to find a efficient way of union two lists together. And then for each of the possibilities, the possible previously state, we check the current state. Mm, yeah, actually, so for this problem, the DP is not for DPI, right? Uh, it's not the DPI, it's not traditional DPI equals to DP I minus one state. As you guys can see, actually we're always updating the next states because you know for current people here, we have the current people J here, right? We have the current people skill here, and uh, and we have the previously DP state, and now we're getting updated skills here. And as you can see here, since we're doing an OR here, right? So the updated skills will always be equal or greater than the previously skills, okay? And yeah, so basically in this case, we are at the current I here, we're trying to get a bigger value, the next value from the current state. So it's a little bit different as the as this one. It's not the so in this case it's gonna be I equals to from DPI, we're trying to get DP I plus something, x plus I. So that's the difference between this problem and the traditional DP problem. And yeah, I believe the reason being is I mean, the key in our case, the DPI here, is the is the is the skills, is the skill sets here. And let's say we have skill set, let's say A, B, D, E, and G. Let's say the current skill set is this one. I'm just listing all the the detail of the skills. If we're trying to if we're trying to I mean calculate current DP skill set by the previously state, okay, then I believe it's gonna be hard because so what's the previous state, right? The previous state is gonna be basically all the combinations of the current skills, right? The previous state is gonna be either A, B, D, E, or A, B, D, or or anything, right? Basically, we have to somehow try to find all the combinations of the A, B, D, E, G, all the subset of this, and then we try all of them, which will be too hard. Yeah, yeah, because you don't know the previous state. Because the previous state, one person could have different, um, could have more than one skills, and let's say you have people skill here, right? Let's say you have people skill and you said, okay, so I just need to for the current skill, I just need to if I have DPI here, I just need to exclude anything. I just need to exclude all the skills that the current people have from my current state, and then I can get the previously state. But that's no, also not true because we're doing an OR here, right? Basically, what it means that let's say the current people has the skill A and B, okay, and then you say, okay, so to get to the A, B, D, E, F, if I remove the current A and B, I only need to check the state of D, E, G here. If I remove A and B, but but that's not always true, right? Because the previous state can also include B here, right? It's not that it's not necessarily only having this DEG. The previous state could also be a BDEG, right? Because with that, when you add A and B, you also get ABDEG. So that's why it's making this problem really hard if you try to do a uh, try to get the current DPI from the previously state, right? But instead, if you are thinking it forward instead of backward, with current people skills here, right? And we have all the previously state here. okay? And then for other previously state, all we need to do is we have a current people skill, and we just need to do a people skill or the previously skills, and then we have updated skills. We just need to get the back, basically the 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 best value, right? Uh, for this updated skills for each of the previously state, and in the end we simply return that. Okay. Uh, I think I already tried my best to explain this problem. And yeah, I don't know why it's really hard for me to explain this one to you guys. Mm, yeah, maybe it's because I haven't really f fully understand when should I use a DPI from to get DPI from DPI minus something, and when should I use a DP to get the DP from DPI to get the DPI plus something. I think that's something I also need to think about it. Anyway, I think I will stop here. Thank you so much for watching the videos, guys, and stay tuned. I'll be seeing you guys soon. Bye bye.